Okay, question 5 asks us to write a piecewise function. So, looking at this graph, I kind of see 1, 2, 3, 4 different pieces. Piecewise function can have as many pieces as at once. Usually 2 or 3 is the most common, but nothing wrong with 4 or more. So we got to come up with the equation of each of these lines. So I can see this guy has a y-intercept of 0 and a slope of 4/6, which reduces to 2/3. So I can do mx plus b. Since b is 0, of course we don't need to put that. And the next one is a horizontal line. It always has a y value of 6. And we've got the third one. I can see his slope is down to right 4. That reduces to -1/2. But his y-intercept's a little bit harder to find because you can't see where it hits the y-intercept. But since the graph's made for you here, you can just copy this slope over a couple of times. So if it had kept going, it would hit here. If it kept going, it would hit here. So looks like the y-intercept of that graph would be 10. So -1/2 x plus 10. And then I'm going to do the same thing with this one. The slope is down 4, right 4, so that reduces to -1. Of course, be careful with the scale here. Usually one tick mark means a value of 1, and in these it means 2. And to find his y-intercept, I'm going to pretend like he keeps on going. And, well, that's a little problematic. So I guess I could extend my graph here and then look and see where it hits. Looks like it hits up here at about 14, 16, 18. So if you're careful enough, I think that method would still be fine. But to give you some options here, the other thing that you could do is just use some algebra. If you know how to write point-slope form of a line, which you're supposed to know how to do anyway, and you know that this has a slope of -1, you can simply plug in any points you have, like 16, 0, and then if you solve this for y, then you can see, hey, he has a slope of -1 and his y-intercept must be 18. So you got 2 options there on how to do that. Continue the slope backwards until you see where it hit the y-intercept. Just be super careful since it doesn't hit on the graph. Or plug in the slope and plug in any point that you know is on this line. I just picked this one, but any point on the line would be fine. Solve it for y equals, and then you should be able to see the slope. Yeah. Yeah, I don't know why I did that. 16. Thank you. Now, of course, the other part to a piecewise function is we have to figure out when each of these exists. So this one, x values can be equal to 0 and bigger than 0, but then they have to be less than 6. Open circle, so don't include 6. My red line, my second equation, only exists from 6 to 8. Looks like it can equal 6, and looks like it can equal 8. This is a filled-in circle. My purple line exists from 8 to 12. Looks like it's hitting 12, and it looks like it's hitting 8. Now this is a little bit picky, but technically to be fully math correct, you can't say that this line hits 8 and this line hits 8. It's kind of like you're counting that point twice, which messes it up passing the vertical line test. So it doesn't matter which one of these you keep, but you should only keep one of them. You shouldn't hit 8 more than once. Okay, and then finally 12 to 16. That's the last one. Looks like it hit 16, so that has to be equal. looks like it hits 12, so you can either put the equal with this 12 or the equal with this 12. But you shouldn't count that point more than once. So similar to graphing a piecewise function, if you can write an equation of a line, then you can write a piecewise function. It's just a little more tedious because you have to do it multiple times for one question. Okay, there's multiple correct answers to the second part. Rewrite the first piece to make the function continuous. So if we were to take this graph, continuous, remember that means that there's no breaks in the graph, no holes, no jumps. This is a jump. There's lots of ways you could do this, but I think probably the easiest, do you see how if we just shifted this whole thing up to, it would fit here perfectly? Okay, well how do we shift a graph up to? Alright, so the first graph, if you added this +2 to it, then it would be continuous. There's other ways to do that as well.
No, I just did y equals x.
Yeah, you just change the slope. That's fine too. Okay, and then finally, for this continuous function, so now that we've pushed this up, find these values. So f of 14 is asking for the y value when x is 14. It looks like it's 2. When x is -2 would be over here. Graph does not exist. When x is 6, looks like we have a y value of 6. And when x is 10, boy, I don't know. I think it might be 5.
X 5, yeah.
So, but to be really sure, again, this is where algebra helps us when we don't want to eyeball something. I can take the equation of this line, plug in its slope. I could plug in a point like 8, 6. And then if I want to know when x is 10, we could plug that in for x and then solve. That gives us something to solve for y. So this would be 2 times -1/2 would be -1. Add the 6 over, and it is 5. So I was pretty sure it went through 5, but just in case it was just close to 5, we can do this. So again, all I did is I wrote the equation of that line, plugged in its slope, plugged in any point that I knew the line went through, plugged in the x value that I wanted to know the y value for, then I had an equation that only had y, so I could solve it for that. Okay, any parts of number 5 you want to guys ask about or want me to talk about again?
For the last one in the piecewise function, is it 16y that has a hole in it?
I'm sorry, what?
For the last part of the piecewise function, is it 16 the one that has a hole in it?
It just looked different when it was printed off.
Oh, it doesn't?
Yeah, it just depends on how you want to call it. Like, I think this is supposed to be a filled in circle. Yours may not have printed off great. But if you thought it was an open circle, then yeah, you should have left off the equal too.
Why is 12 left off of that?
Because I included 12 from this function.
Right.
So I was already hitting that point from the purple line. So you just don't want to hit that point more than once.